Alright, so on our test review for Unit 1, we're going through the answers. You want to try these on your own before you watch the video. Unless you're totally stumped, then of course, use this as a resource, but this is to check your answers with. So on the first section, it names a location that has no size. That would be a point, and we represent that with a dot, but it's a point. And the notation, for example, if this was my point, the notation would just be letter A, whatever capital letter it is. Has no thickness and extends forever is a line. If I'm going to picture it, it's going to have two arrowheads and 2 points on it. That way I can notate it correctly, not with just two letters, but with a line on top, two arrowheads. A part of a line that starts at an endpoint and extends forever in one direction is the key phrase. That would be called a ray. And for a ray, I'll have an endpoint, and it's going forever in one direction. I'm going to write those two letters with a ray on top. It is so dang important that we understand that your first letter has to be the end point, and your ray is always pointing to the right. I do that in blue for emphasis. Part of a line consisting of two endpoints and all the points between them is a segment. And if it's a segment, then it looks like this with two endpoints. I would write those two letters, and I would put a segment, no arrowheads on top of that. A figure formed by two rays with a common endpoint. Okay, this would be what we would call an angle. Two rays with the common endpoint going opposite directions is what we talked about. We'll use opposite rays for this, building off of what we've actually talked about. So if I got a ray going this way and a ray going this way, right? And in that case, we don't have a specific notation for opposite rays, okay? Now, if this was talking about angles, we do for angles. We just have not discussed that this year. So that one we can kind of gloss over. Number 16, we're using our term bank here. Okay, yeah, sorry, our terms right here. We are not doing angle, but that's probably what was meant when we did this last year. So don't worry about that. Moving on, 16, 17, 18, and 19. So I'm going to be just putting up on the screen the definitions. So for parallel, number 16. So parallel is right here. Lines that never intersect. And then we got perpendicular. So we go over here. Right next to that, perpendicular lines, lines that intersect at 90-degree angles. Then we have angle bisector. Okay, let's see if I can scroll. Nope, don't do that. Angle bisector. If you see it, say something. I just won't be able to hear you. Ha 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 ha. Angle bisector, okay? We have angle bisector on the screen, and we also have segment bisector on the screen. Angle bisector is a line segment, ray, or plane that cuts an angle exactly in half. A segment bisector is a line segment, ray, or plane that cuts a line segment in half. Notice that they create congruent angles, congruent segments, respectively, and we label them with tick marks to show that they are congruent. So that was segment bisector and collinear and coplanar. Okay, let's see if I can scroll up. Don't do that. Alright, collinear and coplanar are both right here. Collinear says lying on the same line, and coplanar lying on the same plane. To the right of them, you have the non-examples of non-collinear and non-coplanar. So that'll knock out two birds with one stone, number 20 and 21. Looking at number 22, we're supposed to do two things, okay? Measure and classify. BEH. So I'm doing this in red, so BEH looks like this. What kind of angle does that look like to you? Okay, that is an obtuse angle. Now, what I'm going to do on these is I'm going to switch over to paper because I'm going to actually measure these with a protractor. Okay, so we're looking at number 22, taking my protractor, and I'm going to measure BEH. Now, I'm going to extend this line so I can actually see it on my protractor. Okay. Let me see if I can actually pick up my protractor. It's giving me some trouble here, which is unfortunate. Alright. Zoom out a little bit. So for BEH, remember, line up the circle on the vertex, line up your line, and you can see BEH, that is obtuse. It is bigger than 90. I'm looking at this number. I'm not going to use the inside number. I'm going to use the outside number. So 110, 120, 130, 140, and it looks like it's 1, 2, 3 past. 143 degrees for BEH. So obtuse, 143 degrees. Now let's do ADE. ADE. Okay. So I'm going to position it like this. Okay. So I'm going to put the circle on the vertex. I lined it up, and ADE is obtuse angle. So I'm not going to, on this time, my obtuse numbers are on the inside. So it might be kind of hard to see for you, but those are going to be 120, 5, 126, 127. About 127. If yours is a little bit off, hey, it's all right, because it's close enough for me. Then this is measure and classify IEG, from I to E to G. That's a little acute angle right there. So I'm centering it up right there. Okay, from I to E to G. Okay, so I look over here. I'm using the angles on the inside, the degree measurements on the inside, because they're smaller than 90, because that's acute. So make sure I'm lined up again. 10, 20, 35, 36, and 37 degrees. Okay, that is acute. 37 degrees. So, they ask, what angle is supplementary? If you remember, supplementary adds up to 180 to HGI. HGI is right here. What next to it would make a straight line? I would say this angle right here, right? That's DGH. Angle DGH. Those two would be 180, straight line. Then we have what is complementary, meaning adds up to 90, from DEG. DEG is right here. How do I make a 90 degree angle? I need this angle right here. It's GEI. So angle GEI. Okay? So I know how to do that one kind of by hand to show you, but on these, I'm going to use a protractor. On your test, you're going to have to use a protractor. Switching back over to here, we're jumping down to number 27. We see that we have an angle pair that makes a straight line, 180 degrees, right? So that's called a linear pair. We had a quiz on this information. You could also call these supplementary. So what do I do if they are a linear pair? I'm going to take this part plus this part equals the whole thing 180. So 3x plus 10 plus 2x equal sign 180. Combine like terms. 5x bring down plus 10 equal sign 180. Get rid of that loner. Minus 10 minus 10. 5x equals 170. And then we divide to get rid of our coefficient. X is going to equal 34, if I'm doing my mental math correctly. I believe that's right. So 34 degrees. Okay. And then 28. These are across from each other. So we've said if they're across from each other, they're called vertical angles, okay? So if we have vertical angles, we know that they are congruent, therefore their measurements are equal. So you can kind of think of it like an equal sign goes between them, like that. Well, let's rewrite it. 4x plus 10 equals 7x minus 5. We get rid of the smaller x, minus 4x, minus 4x. Cross those out. Bring down 10 equals 3x minus 5. And then we can get rid of the loner, add 5 to both sides. 15 equals 3x. And then we get rid of the 3 coefficient by dividing. 15 divided by 3 means x is equal to 5. Okay? So x is equal to 5. Cool. On the next page, we have, points MATH are collinear. T is the midpoint of MH. So you need a label. M in H, T is a midpoint. Okay, so what we want to do is label it. Now we're going to eye this. It did not say the word construct, so we do not need to use a compass and a straight edge. You're just kind of eyeing it, which is fine for now. And then it says A is the midpoint of MT, so between A and T, I'm going to put a midpoint for that, put an A. So I know basically MA and AT, these are congruent. And then I know MT and TH have to be congruent. So let's think about this. It says AT equals 9. I'm going to label that. So this is 9. What is the length of MT? Well, if AT is 9, what's MA? Has to be 9 because we know this A was a midpoint, so they got to be congruent. So all the way from M to T has to be 9 plus 9, which is 18. Okay. If I asked you for MH, could you figure out MH? Could you double 18 again? That's the question. So, look at number 30. We're going to have to do some construction, so I'll switch over again. So, on number 30, copy and bisect. Notice there's two things to do here, okay? So, to copy an angle, I'll remind you, we must first draw a segment, put a point, we make an arc on both that match, then we got to measure from here to here. That way we can come over here and make that second mark. If I don't see that second mark, I don't believe that you constructed it. Okay? So again, there's my second mark, and I draw my line through that. I have constructed a congruent angle, but now I need to bisect it. So I'm going to use that first arc, that's fine, and whatever size I want, I'm going to use it to make my x's, my x, so to speak. They should look, arcs. They should be arcs from each of these intersections, but it kind of makes like an X, marks the spot. So we can draw a line through that, through the vertex. So we have bisected a angle that we copied. Now, if I'm going to describe the relationship between these two new angles, what would I say? Those little tick marks mean that they are congruent, okay? So I would actually write a full, complete sentence, but I would use the word congruent in my sentence. I don't have the time to do that right now, but you do. So make sure you do that on number 31.